All right, so today's topic is describing quantitative data with numbers. So we're going to talk a little bit more about mean and median, and then we're also going to look at quartiles, and we're going to take a look at how to actually determine when something officially counts as an outlier. All right, so first things first, mean. I just want to put some symbols down that we're going to see and some formulas just to kind of formalize our definition of the mean. So first of all, most of the time we'll be using this right here, which we just say as X bar. All right, and it is the sum of the observations divided by n, which is the sample size. So basically, what you've learned for the last 10 years on how to calculate an average. Add everything up, that would be the sum of the observations, divide by how many you have, that's the sample size. The other way that you sometimes see this written is x1 plus x2 plus ... all the way up to x to the n, and then you divide that by n. And then the other symbol that we use a lot in this course, so let me just put it here, would be the summation symbol, which again just means add everything up. So you might see that written like this. And again, it all means the same exact thing. Just add everything up and then divide by how many you have. Now, the way we actually say this, so when you see this symbol, we actually just call that X bar. So if I say X bar, that's the symbol that I'm referring to, and we use that for the average. And specifically, this is the symbol that we use when we're talking about a sample. So a sample is just a smaller part of a larger population. And when we're dealing with an entire population, you're going to see this, which is mu. And that's for when we're dealing with a population mean versus a sample mean. So just some things that are good to know and be aware of as far as means in this class. All right, you might see X bar when we're dealing with samples. You might see mu when we're dealing with populations. But if you see either of these symbols, that's what it's referring to. All right, median. We've got the midpoint of the distribution. All right, which is just a fancy way of saying the middle. And if you want to know like where the middle actually falls, when there's an odd number of observations, the center observation can be found using this little formula, n plus 1 over 2. All right, so this isn't the value of the median. It just tells you which value the median is. So like if you have 10 or 11 observations, 11 plus 1 would be 12, divided by 2 is 6. So you know that the sixth observation is your median. And then when there's an even number of observations, you just take the average of the center two observations. So for example, if you had 10 observations, the middle falls between observations 5 and 6. So you would average those two together and find your average that way. All right. So let's just do a quick example to make sure there's no confusion here. Set 1, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 observations. So 15 plus 1 divided by 2 is 8. So I know the eighth observation, 1, 2, 3, 4, 5, 6, 7, 8, is my median. So this value right here would be my median. All right, on this one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that tells me that the middle is going to be between 6 and 7. So 1, 2, 3, 4, 5, 6. So the middle is actually between these two observations. So because it's between those two, I have to just do 15 plus 20, divide by 2, and that will give me 17.5. All right, so just a quick example there just to make sure there's no confusion about any of that. So these pros and cons we've already talked about, but the mean takes all values into account, so that's good. But the downside of taking all values into account is that it can be greatly affected by outliers. The median is not affected by outliers because you're only looking at one, maybe two numbers, but the downside is you're not taking all the values into account, so you're missing out on the variety of values that could be in a distribution. All right, so again, this is just sort of a recap and then making sure that we're familiar with some of these symbols and things like that. All right, let's flip over to the back. So comparing mean and median. All right, so this is one thing that you're going to want to be able to do. If I tell you the shape of the distribution, you should be able to tell me something about the relationship between the mean and the median. All right, so when a distribution is symmetric, the mean is going to be approximately equal to the median. All right, they might not be exactly the same, but they're going to be very close. When an observation is skewed left, you have these low values dragging down the mean. All right, so you have these low outliers dragging down the mean. So when it's skewed left, the mean is always less than the median. All right, and again, remember the median is the 50% mark. So if you have most of your observations over here, the 50% mark is going to probably happen somewhere in this area, but then the mean is going to get further dragged down because of these lower observations. All right, now skewed right, the exact opposite thing happens. All right, the mean is going to get dragged up by these observations out at the end of the tail, whereas the 50% mark is probably going to be back in this section. So the mean is always greater than the median. So there might be questions where like I give you the mean, give you the median, don't give you a picture, and then ask you to tell me what the shape of the distribution is. And if the mean is way bigger than the median, you're going to tell me that it's right skewed. If the mean is way less than the median, you're going to tell me it's left skewed. If the mean and the median are about the same, you're going to tell me that it's symmetric. All right, so there's going to be questions about that. There also might be questions where I just give you a picture and then ask you which is going to be larger, the mean or the median, and so on and so forth. So you just need to be familiar with this relationship. The rule is that the mean is pulled in the direction of the skew. So if it's skewed right, the mean gets pulled to the right, which makes it larger. If it's skewed left, the mean gets pulled to the left, which makes it smaller. And if it's symmetric, it's stuck in the middle, and it's approximately equivalent to the median. All right. And if it's perfectly symmetric, they will be equal, but that would, a lot of times data is not going to be perfectly symmetric. So there might be a little, variation between these two things. And then again, this bottom part we've talked about before. If the distribution is perfectly symmetric or even mostly symmetric, we're going to use the mean as the measure of center. If the distribution is skewed or if there are outliers that could affect the mean, we're generally going to use the median. All right, so again, this part is sort of recap, but this is sort of the new information that you need to internalize because there will be questions that pop up about this sort of stuff. All right, so let's move on to our new measurements. All right, so another measure that we have is IQR. So the interquartile range. All right, that's what IQR stands for, is the range. And because it's a range, that means it's a single number. All right, we're using the statistics definition of the word range for the middle 50% of the data. All right, and the calculation for it is just Q3 minus Q1. All right, so this is what IQR equals. All right, so next question is, all right, what is Q3 and Q1? How do we find Q3 and Q1? All right, we find Q1, quartile 1, and Q3 by kind of, again, putting the data in order. And then Q1 lies 1/4 of the way up the data set, and Q3 lies 3/4 of the way up the data set. And then again, to get your final answer, you're going to do this Q3 minus Q1. So let's talk about how we can find Q3 and Q1. So if you are doing it by hand, you start by finding the median. So again, we've got an n of 15, so we know that 15 plus 1 divided by 2 is 8. So the median is the 8th observation. 1, 2, 3, 4, 5, 6, 7, 8. All right, this right here would be our median. Now, when your median is a single number, what you then do is find the median of only the numbers to the left. So forget the 20 disappears, and we find the middle value of just these observations to the left. So on the left, there's 1, 2, 3, 4, 5, 6, 7 observations. So the middle of 7 observations is going to be observation 4. So this right here would be our Q1. All right, so we basically kind of wall off and just find the middle of this section right here. And then we do the same thing over here. We kind of wall off this section and find just the middle of these. So again, it's going to be the 4th observation because there's 7 on the left, 7 on the right. So this would be our Q3. All right, and then the median would be 20, Q1 would be 14, Q3 would be 27, which means if I was finding the IQR, it would be Q3 minus Q1, or 27 minus 14, or put another way, it would be 13. All right, and that would tell me how spread out the center 50% of my data is. All right. Now, the other way to do this is to just put it into your calculator. And honestly, I would probably recommend you just put it into your calculator so that you don't make some sort of silly mistake counting. All right, so in stat edit in L1, I've already put this first data set that we're looking at here. All right, so this is that first one that we looked at. And then what I need to do is I just go to stat, calc, one variable stats, make sure it's using the right list. So that one's in list L1, so I can go second and then the 1 key, that'll bring up L1. I can hit calculate, and it'll give me Q1, right there's 14. It'll give me the median, it'll give me Q3, which is 27. So again, I wouldn't do them by hand just because it's easy to like miscount or goof up or not remember it correctly. Just put it in the calculator, run one variable stats, and it'll give you this information. Now, I am going to show you another one by hand just so you can see how it works when the data has an even number of observations. So this one is size 16. So that means the middle is going to be between 8 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so the middle is going to be right here between these two. So our median is going to be 20.5. Now, on the one above, when we were doing the quartiles, we sort of ignored the 20 and just looked to the left of the 20 and just look to the right of the 20. But in this case, our median is actually in between these two numbers. It's not 20. It's not 21. So when we're calculating the midpoint of the lower half of the distribution, this time we do include the 20 and we do include the 21 because the median isn't actually either of these numbers. So they have to be included when we do to the left and to the right. So then I would say, all right, the left has 1, 2, 3, 4, 5, 6, 7, 8. So that means, again, it's going to fall between two numbers. All right, 14 and 15. So Q1 is going to be 14.5. Same thing over here. It's going to fall between 26 and 27. So Q3 is going to be 26.5. All right, so let me just fill those in. 20.5, 14.5, 26.5. So again, the IQR would be 26.5 minus 14.5, or put another way, the IQR would just be 12. All right, but the whole like having to remember that like when it's odd, you don't include the median and just go to the right and to the left, but when it's even, you have to go through the middle, so you do include those two numbers. It's just one of those things that like, do you really want to try to like have to remember that? And like during a test, are you sure you're not going to goof it up? When you can just put it into your calculator, go to stat calc, one variable stats. This time I put the data in L2, so I'm just switching that over to L2. And again, it's going to give you those answers. There's 14.5, there's 20.5, 26.5. The only thing you have to be careful of when using your calculator is to make sure that you type in everything correctly. Because if you type in the wrong numbers, it could throw things off and give you a different answer. But you know, maybe the best way is to do it both ways and just make sure that you're getting the same answer on both, because you're less likely to make the mistake twice in a row. All right, but again, that's how you can find quartiles. That's how you can find medians, and you know, it changes based on basically whether you have an even number of observations or an odd number of observations. All right, so again, it's just a measure of how spread out the middle 50% of your data is. All right, so the other important part of the IQR is it's going to allow us to determine whether or not we have an outlier. All right, so I said that pretty quickly we'd come up with a rule on when something counts as an outlier, instead of just saying like, oh, it looks like it breaks from the pattern. So the rule is the 1.5 times IQR rule. All right, so an observation is considered an outlier if it falls more than 1.5 times the IQR above the third quartile or below the first quartile. So what does that actually look like in terms of the calculation? So it's going to be Q1 minus 1.5 times the IQR, and it's going to be Q3 plus 1.5 times the IQR. So this is going to detect large outliers, so outliers that are really big, and this is going to detect small outliers, so outliers that are really, really tiny compared to the rest of your data. All right, so we check in the upper direction and we check in the lower direction to see whether or not we have any outliers in our distribution. So here we have an example. Travel times to work for New York residents, times in minutes. All right, so this is how long it takes New York residents to get to their place of work. And if we scan the data quick, we do notice that we have this 85 here that seems substantially bigger than all of the other ones. So this is the one that we're kind of curious about, and we're wondering, does this actually count as an outlier? All right, so to figure this out, we have to start by finding the quartiles. All right, we can't figure out whether something's an outlier unless we first figure out what the quartiles are. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 observations. So that tells you that the middle observation is going to be between the 10th and the 11th observation. So 3, 6, 9, 10th, and the 11th. So your median is going to be 22.5. Will Peyton Minbiel please come to... All right, so the median's between these two numbers, 22.5. Because it's between two numbers, when we're finding the quartiles, we're going to go 25 to 85 and find the middle of that. And we're going to go from 20 down to 5 and find the middle of that. All right, there were 20 observations in total. So that means there's 10 on each side. So the middle of 10 is going to be between observations 5 and 6. Now for this one, the average of 15 and 15 is just going to be 15. So that's our quartile 1. The middle of 1, 2, 3, 4, 5, this one and this one, 40 and 45, is going to be 42.5. Again, this is our median. Now, if I'm doing this on a quiz or a test, I'm probably double checking. So again, I've already entered the data into my calculator. It's in list L3, but I can go to stat, calc, one variable stats, go to L3, hit calculate, and I can see that Q1 is 15, which matches what I got. The median was 22.5, which matches what I got. Quartile 3 was 42.5, which matches what I got there. All right, so again, good idea just to do all of those pieces and kind of check your work. So determining whether there's an outlier, find Q1, median, and Q3. We just did that step, so we're good there. Find the IQR. All right, now again, remember the IQR equals Q3 minus Q1. So let's do that over here. IQR equals Q3 minus Q1. So IQR equals 42.5 minus 15, which gives us an IQR of 27.5. All right, so there's our IQR. So we've done this step. Find 1.5 times the IQR, because again, that's what we're adding and subtracting from our quartiles. So I can just do that right here, 1.5 times 27.5. And that's going to work out to be, let's see, 27.5 times 1.5 is 41.25. All right. So there's our 41.25. This is what we're going to need. So there we found that. Now we need to find our fences to see what are the limits for our outliers. So we've got our lower outlier, which is Q1 minus 1.5 times the IQR. Well, we already found Q1. All right, Q1 was 15. All right, we found 1.5 times the IQR. That's our 41.25. So if we subtract 15 by 41.25, we're going to get negative 26.25. All right, so that's saying for something to be an outlier on the left-hand side, it would have to be below negative 26.25, which, given the nature of our data, is clearly impossible. Your travel time can't be negative minutes. So given how low our data is, our data are, you can't actually have a lower outlier in this scenario. All right, now let's do the same thing for our upper outliers or our higher or lower. Yeah, we'll call it higher. This one would be Q3 plus 1.5 times the IQR. All right, so Q3 plus 1.5 times the IQR. Now Q3 we know is 42.5. All right, we found that up here. 1.5 times the IQR is 41.25. So we've got that right there. If we add those together, we're going to get 83.75. All right, so that's our higher limit or our upper limit. Maybe upper is a better word. Upper limit for the outliers. All right, so negative 26.25, positive 83.75. So anything, so we did this right there. So anything below negative 26.25 and anything above 83.75, all right, counts as an outlier. So determine the existence of an outlier. If we look at our data, we only have one observation that's above 83.75. We have no observations below negative 26.25. So our conclusion is yes, 85 is an outlier. All right, so that's the process for determining whether or not you have an outlier. So going forward, it's not just going to be, oh, like that point deviates from the pattern. It's going to be, okay, is that point classified as an outlier? Now, usually I get the question, well, what if it had been exactly 83.75? The definition is more than. So if it's equal to, we're technically not counting it. So sorry, the definition is more than. So if it's equal, we're technically not going to count it as an outlier. But at that point, it's so close that you probably want to just examine what effect it has on your mean or your median or whatever other calculations you're doing. You know, if leaving that one value out dramatically impacts your other statistics, it might be a good idea to report it both ways. You know, this is the mean including this data. This is the mean excluding this data. It's right on the edge of what we would normally consider an outlier. So again, for purposes of this class, when we're identifying an outlier, it needs to be above or below the benchmark, not equal to the benchmark. But in terms of like real world application of this concept, if you've got something that close to the cutoff, you should probably run your statistics both with and without that piece of data to sort of see what impact it's having, so that it doesn't, you know, unduly affect your results in one direction or another. So again, there's sort of the hard and fast rule, and then there's like the common sense approach of, all right, it's clearly close, so let me take a look at what's going on here. All right, so I hope this was helpful. If you have any questions, feel free to reach out. And if not, I will see you when I see you. All right, bye.